Okay. So the next one here it is.
Sir, screen is not available, sir.
Yes, yes, sharing 1 minute. Okay. So this is what basically swap method. With help of this, we are trying to swap the values. The values of M and N we are trying to here swap. Swap meaning is what? Interchanging. Since we are passing the parameters here by value, so they cannot be getting changed. The original variables M and L will not change in this case here with this method. What happens is here values they get passed to this function. Okay, but whenever you pass the function, only values, original variables will not be passed in this case. When you pass original variables addresses, in that case data can change. Okay, but since you are just copying, so whenever this method is called, temporary variables M and N get created. Not M and N exactly, some integer type of variables they get created. Okay, so those variables only, the values of those variables get interchanged. There is no change in the original variables when you go with the call by ref, call by value. But whenever you go here with call by ref, in that case the values can change. M value comes into N and N value comes into N. You can see the code here, how they are getting here interchanged. Okay, if you come here, swap, ref intx, ref inty. So here x equal to x plus y equal to x minus y, x equal to x minus y. So ultimately what happens here, the value of x and y are getting interchanged. Whenever you go here with the ref. And how do we call it? So to call that one, here you have to use the ref keyword. We call here swap ref m comma ref n. Like this, we are actually calling the swap method. What we are writing here, ref m comma ref n. By reference actually, by passing the reference of the variables, we are actually here calling the method. But here, by passing the values of the variables, we are actually trying to swap there. So here there is no change in the original variables, but here original variables value is going to be getting changed. They actually here get interchanged. The value of m comes into n and the value of n comes into n, that is. So like this, what is happening, they are getting here interchanged. Then after that, we have seen one more thing, num2 words. Num2 words is nothing but a method we have written here. Okay, so this method is basically to convert the given number into words. For example, you enter 125. It's going to print for us 125. Okay, when you enter 125, it's going to give you 125. Like that, this is going to print. Okay, for that purpose, what I do here, I have declared an array called static string array. This is digits in words. Okay, this is array. Array, what exactly array? Array is nothing but aggregate homogeneous data. It's aggregate data. Okay, aggregate homogeneous. Under array, you can hold number of values. Okay, you can hold under array number of values, but whatever value you want to access, you have to use actually their index. Like here, digits in words of 0, then 1, then 2, then 3, like that you can access. So such things are called as arrays. Arrays are nothing but aggregate. They are called as aggregate homogeneous data. Similar data you have in the arrays. So this is what here, static string array. You can declare a string array in this manner. Data type followed by empty set of square brackets. And this is what exactly a one-dimensional array. This is a one-dimensional array. So what we do here, digits in words equal to, we assign here some 10 values, 0 to 9. We assign total 10 values, 0 to 9. You can access them using the index. Very first element you can access using 0 index, next one by 1, then by 2, and last element you can access using actually size minus 1. Size is how much here for us? 10. 10 minus 1 is here 9. Very last element you can access using the 9. So same logic I use here, and with the help of this I'm converting the given string into the given number into here words. Okay, so when you go here, digits in words num%10. What happens in such cases? Digits in words is nothing but here an array num%10. For example, you give number as 525. When you divide 525 with 10, what remainder you get? You get 5. So therefore here digits in words of 5 is going to be giving you 5. So like that, this method is working here, and this method is called as here recursive method. As long as this method, this function is, as long as the num is greater than or equal to 10, same function we are calling here, but with a different parameter. So this is called as here recursive call. You are calling the method recursively here. Okay, so this is called as here recursive methods. Okay, to understand certain concepts actually, definitely you need to have some C background or C++. Like here, reference variable you take. In the case of reference variable, so how exactly the memory is getting saved, how to access memory. So, I mean, memory, in the memory, you have actually numeric values. In that location, actually data gets saved. Okay, for that, little background is required. Software background is required. Huh? So otherwise, you can't actually, easily you can't understand. You need to strive a lot for that. Okay, you need to struggle a lot to understand in such cases. So this method is num to words, which is converting the given number into words here. Once again, let us run this and see what result we get. So we are coming into swap method. I just press F5 here, then try to see the result. What do we get here? So when you take 96710 in words, is printing it as 96710. Okay, 96710, 96,710 that is, but when we convert it to words, we get 96710. So this is exactly what the number in words. We are converting the even number into words. So this is called as here number to words conversion or number to string conversion here. This is 96710. We print it as 96710. So using this recursion concept without writing much code, we could achieve this. Otherwise, you need to write a lot of code for that. Without writing too much code, okay. So in a simple way, we have converted this into here, into the words. Okay, so this is called as here a recursive function. Okay, so this is nothing but actual recursive method, recursive function here. Recursively, it's calling for us. Okay. Next thing, here this is related to methods. Methods, first thing is what? You're calling the method by value. Okay. Next thing, we are overloading the method. That means same method name. Here you have only 2 parameters, but here you have 3 parameters. When you look at swap, here by value you are copying, and here by reference you are copying. Okay, so this is also overloaded here for us. This is called as overloading. Same method name, when you have different set of parameters, that is called as actually overloading. We have overloaded the method here. This concept is very important in the OOPS. When you talk about object-oriented programming, so it is called as actually, it's called as overloading. We are overloading the method here. By value, we are doing it. Okay, so here it is by value and by reference. Next thing here, what we are doing, we are converting the given number into words. So using actually recursion. Today we look into one more type of method. That method is going to be here using optional parameters or default value for the parameters. So I define in this manner, public, then this is static, followed by here, I go with a double, then here it is root. Okay, it is root actually, then this is here. It is nothing but double num. Okay, then here index you need to take int index equal to here it is 2. So this is called as here default value. Public static double root double num int index equal to 2. So when you go with the root normally without passing second argument, automatically you get the square root for that. But when you specify index in that case, that particular root you are going to get. Okay, so here to find out that you have one mechanism called like return followed by math dot. So it is going to POW. POW is nothing but power function. We take the num and we are going to raise it like 1 multiplied with 0 followed by here index. Like this, we are trying to do it. Okay, it's not 1 multiplied, it is actually like this is 1 multiplied with here 1 multiplied with 1.0. We take like this, then we try to divide with the index. It's going to be returning that particular value for us. So this is going to be giving you, when you don't specify the second value, automatically it's going to take actually the square root, otherwise you get the cubic root. So now here what I do, I just want to comment this part. I'm commenting this part here. I can go here with the multi-line comment in this manner. Star slash. And you go here and after that, go with the slash star. Okay. Now here, I want to find out square root. Here just I write num num equal to some value I can assign here. Okay, I can assign in this case some number, like it can be, first I want to go with a random object. Let me create here a random object. Okay, so here I go with the double followed by nth root. Okay, object RND, then dot. It is next we take followed by here. Okay, this is number we take first, not the double value. int num we take. So next this is here followed by, we go here with the like 10 followed by here up to something like 1000 we take. Okay, 1000 we are going to be taking here. Next, it is some random number. What is the number? We don't know. Similarly here, int index equal to. Okay, index equal to here again, object RND, then dot next, here followed by, so 3 comma, up to how much we can take, up to some 7 we take. 7 times we can find the index. Like this, we are going to take it. Okay, so like this here, we have the 3 comma 7. We have taken here 3 comma 7. So now what we do here, we try to find the, root here. So go with the double followed by here nth root equal to, here I go with the root function, then this is num. Okay, num. I'm not specifying the second argument here. So go with console.writeLine. Then here write. Okay. Here we need to write it as the square root okay, the square root of the number is, we go with 1, then here we specify the square root. So here we go with the num, followed by here we go with the nth root. We try to print here the square root value. Whenever you want to find square root value, you're not giving actually second argument. It is basically optional argument. In the square bracket it's happening, int index equal to 2 is taking. That means what? Its default value it is. We need not specify. When you don't want to specify, automatically it takes 2. But when you specify as per that, it can work. Next, right here, nth root equal to here. Okay, we go here with the root num, followed by, we try to get here 4th root, comma, it is here 4. Right here, console.writeLine. Okay, the here. So what we do here, it is 0, 1, 2, 3 you have. So therefore, let us create here some array. Okay, so what I do here, string array. So string here, write NAR, NA equal to, I write this way, cubic quadratic, okay, then here it is fourth root, okay, fourth, then followed by here it is fifth, then we go here sixth, like this we can take, then it is here seventh. In this manner we take it. Up to how many we take here? 7, 6 roots only we take here. Cubic, quadratic, fourth, fifth, sixth, and seventh. Like this is. Okay, you can take a value. So here write the 0 root, it is actually 1 is here, 2, like this we need to write this. Okay, so what we have to take here in this case, we have to go with this array. What is that array for us? Array is here NA. Okay, we put here NA, then followed by here in the NA using index you can access. What is the index here actually? This is going to be like it can pick a value between 3 and here 7. So here we go with the 3 minus, okay. So we can go here with the it is going to be what value it can pick here? Index minus 3. Accordingly, this can print for us. Let us try to here. So we cannot write here 4. We need to go here with the like index. Okay, index we take and we try to find what value we get. So now if you go here, the fourth root of 325 is 3 point something. Is it correct? The fourth root of 325. So if you take 3.17, okay, if you take 3.1796, if you raise it 3 times, what do we get here? Initially 3 3 is 4, 9, 9 3 is 27, 23 is 81, 81 3 is 243 you get. 3 square, 3 cube, but how much we are getting here? Fourth root equal to that much we are getting. Where is the problem? We can see here in this case. So 0 is cubic, second one is here what? Quadratic, fourth root, then fifth root, sixth root, and seventh root. Okay, so here this is going to be fourth root, not cubic, fourth root only. So this is cubic, quadratic, sorry, this is fifth root. It is going to be fifth root, and this is going to be here sixth root, and this is going to be here seventh root, like this it is. That was basically wrong actually. Here this is going to be eighth root. So that means what here? Whenever you go here with this cubic, quadratic, fifth, sixth, seventh, and eighth. Okay, once again, let us try to run and see the result. Start debugging here. So what it says, see, the sixth root of the number 582 is 2.88, something like that you get. Is it correct here? Can we verify that particular thing? The square root of 582 is what here? 24 you get. Okay, whereas the sixth root of 582 is, we are getting it as here 2.8894, something like that we are getting it. So you can take, this is lying in between 2 and 3. Okay, basically the value is lying between 2 and 3. Let us take 2, you raise it 6 times. 2 when you raise 6 times, what do you get? 2 to 4, 4 to 8. Okay, so 8 to 16, 16 to 32, 32 to 64. And how much you get here? 128 you get, I think. Or 64 you get. When you take 3, you try to raise it. So if you raise 3, 3, 5, 6 times, 3 3 is 9, 9 3 is 27, 23 say how much it is? 81, 81 3 is actually 243 you get. Okay, so when you raise actually 6 times here, 2, probably you get actually, for example, take here, take 2 and try to print it actually here some 6 times. 2 multiplied with 2 here. Okay, X symbol. 2 multiplied with 2 here, multiplied with 2, multiplied with 2 here, again multiply with the 2. So 6 times we are doing it. First, if you take 2 to 4, multiplied here with, what is the next part we take here? We use this part. Okay, then it is going to be 8 multiplied here with this one. So how much we get here? This is going to be 8 8s, 64 only we get here in this. But if you take 3 that many times, 3 multiplied with 3, then multiply with 3, multiply with 3, then multiply with 3, go again multiply this with 3. So what do we get here in this case? 6 times we are raising it. 3 3 is 9, 9 3 is 27, 23 is 8, 243. So 243 is going to be 243 multiplied with 3 is going to be so much we are getting. But when you take here, how much? The 582, the sixth root of 582 is 2 point something we are getting here. Let us try to find here 582 what we get. Go to calculator and see here. Okay, the calculator, here we need to go with the something like scientific calculator. Let us take. In the scientific calculator, we try to find here the nth root. Okay, how can we find here? This one we can take, and with this we can find here. So we take the number 582 here. 582. Then here, okay, 582 first we entered, followed by, we go with this. Sorry, this I need to clear here totally. See, so I need to clear everything first. Okay, I can clear everything. Now I go here with the 582. Go with this, then try to raise it actually some 1 by 6 times. 1, okay, divided by here some 6. We are getting it as 97. So this is something wrong again. Okay, so what I do here in this case, 1 by 6, we need to divide 1 by 6. So that is going to be basically, we need to find here square root x we have actually, otherwise we don't have that mechanism in this. See, we write here. So how to find that particular thing here? X you need to raise y times. Okay, what are the other mechanisms you have? Let us see. Standard calculator, dropping, we have programmer calculator. If we take, do we find here? We don't have any such thing. Otherwise, we can try here. Okay, we can go here and try to do this. Now here in this example, we go with the 582. In the brackets, we put that 582. 582. Okay, then close the bracket. After that, multiply this with 1.0 divided by here, this one. We go with the 6 in this case here. We're getting still 970. There is something wrong here in this case. Okay, what I'm doing, I think is going something wrong in that case. But what I do here, cubic, quadratic, 5th root, 6th root, 7th root, 8th root. This is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. There are going to 5 indexes total. Okay, what I do here, I'm going to pick index between the 3 and 7. So therefore, it can be 3, it can be 4, it can be 5, it can be 6. You have those values. You're going to have actually those values. So here what we do, root num comma index we take. Num comma index we are taking. The 0 root of the number, here what we take, NA index minus 3 we take. Since very first thing is starting with the 0 here, we have to go with here 3 minus 3 only. If the very first one is 3, then 3 minus 3. If it is 4, 3 minus 4 minus 3. If it is 5, 5 minus 3. If it is 6, 6 minus 3, like that we need to take here. So whenever you calculate here, we are raising this num given index times. So what is available in the code? Let us see here. How we are giving here in this case? 1 multiplied with 1.0 divided by here index. Otherwise, instead of doing like this here, you can just go with the 1.0 divided by index. With that, we can actually raise the given number. Once again, start debugging. What value we get here? See. Okay, the square root of the number 552 is 1, it is saying that is wrong. The sixth root of the number 552 is 1, it is saying. So why it is behaving like this, we need to see here. When you divide 1 with index, so it has to be basically, okay, so let us go this way and try to see. With power, we are going to do it. Giving only 1 for us. Always this is giving 1 for us. It can't be like that. Go with debug. Just giving 1 only for us. 1 by index, it has to take always. What's the problem? Where is the problem? Let us put actually here the breakpoint and see. Now try to see the result. The square root we are getting correct. But when you go with the cubic root, sorry, sixth root, it's giving 675 for us. Okay, 675. When you here go with that something like 675, okay, is 2.0961 something we get. Let us try to print even that result. Just 1 minute. So 675 sixth root. Let us try to find from the somewhere from the internet. Find nth root. Okay. So here somewhere probably the code we don't require. So we need to find here. Nth root calculator. Calculate the sixth root. Okay. Of how much it is here for us. When you look at this, it is 675. It takes 2.692 something. That means it's giving you correct result. 2 point, how much it is giving here? 962. We are getting the same result here. 961 something showing here. So therefore, what we have done is here correct in this. Okay. So well, so here what is happening in this case? We are getting actually correct result only. While doing reverse calculation, somewhere we are missing. Otherwise, it's giving you correct result. And this is called as here optional parameter. The parameter is optional. It's not actually mandatory in this case. It's optional. But when you don't specify this parameter, automatically it's going to take 2 for us. Okay, when you go here, when in the code, if you look at the code, in the case of the square root, we automatically takes value 2. So we get square root in that case. But when you go here with the num comma index, this is going to give you nth root. The index value is going to be any value between 3 and 6. It can be 3, it can be 4, it can be 5, it can be 6. So once again, let us run and see this time what value it gives us. So is it going to give again 6th value or some other value? Let us see. Okay, the cubic root of the number 111 is here 4.80 something. Okay, if you raise 4, 4, 4, 16, 16 fours are, so 4 if you take here, 4 if you try to raise, the cubic root of the number 111 is 4, it is saying. How it can be 4? Cubic root of if you take 5, 5 is 25, 25 5 is 125 you get, that is fine. If you take 4, 4, 4, 16, 16 fours are 64. So it is lying in between how much? 64 and next thing is how much here? Here it is 5, 5 is 25, 5 is 125. So it's lying in between actually 64 and 125. So therefore 4.805 is correct for us. It's actually correct value for us, cubic root. Again, if you try, probably you get some other number. Okay, this is saying now fifth root of the number, 228 is. So it is lying in between 2 and 3. Okay, 3 if you raise 5 times. First 3, 3 is 9, 9, 3 is 27. Okay, 27, 3 is 81, 4 times. So 81 into 3 is going to be 243. Okay, it's going to be here 243. So 228 is lying between, in between 225, 225, not 225, yeah, like 243. And other thing is what here, if you take, if 240, 343 or 243, that is actually, because 3, 3 is 9, 9, 3 is 27, 27, 3 is how much? 81, 81, 3 is going to be 243 you get. Okay, but when you go with 3, this is the 3, you go with the 3 actually in that case. So whenever you go here with the 3, how much we get? Sorry, 4 we need to, 3 we need to take. For example, if you take 2, 2, 3, 3, 3 is 9, 9, 3 is 27, 21, 27, 3 is how much? 27, 3 is 81. 81 multiplied with 3 is going to be here 243. So 228 is less than 243, it's correct. Okay, but if you take 2, 2 when you raise here 5 times, you get 32. It's lying in between 32 and that value. So therefore, here, this is correct only again. We are getting square root as well as here cubic root. If you look at 228, 225 is 15 square root. But when you go with 228, it's 15 point something you get. Okay, so that always you need to verify actually. Anyhow, so we are bothered about actually technology, the result, if the formulas are correct, in that case you get correct result. So this is what here, public static double root. When you pass this one, it's going to be finding the nth root of the given number. Otherwise, it's going to find the square root for us. Okay, when you don't pass this one, this is going to be square root, like this here we do. How we do here, we write double nth root equal to root num. We are not passing second argument. So therefore, it's giving you in that case square root. But when you pass here second argument, you are getting actually in that case the given nth root. It can be third root, it can be fourth root, it can be fifth root, it can be sixth root as per this program. So here, how many values we take? We are going to take total. The value can be 3 for this, the value can be 4, the value can be 5, the value can be 6. So 4 different roots you can take apart from the square root. Possible here to find the square root, the cubic root. Okay. Similarly, the fourth root, that's called the quadratic root. Okay, then similarly, you can go with the fifth root and you can go even with the sixth root in that case. But so far we haven't seen quadratic root. Once again, let us try to see the whether we get quadratic root or not. Yeah, this time we got actually quadratic root. So 577 quadratic root is going to be here 4. Okay, that means what here 4 times when you raise 4. Initially 4 when you raise with 4, how much you get? 4, 4, 16, 16, 4, 64. 64 fours, how much you get? 256. Okay, you take now 5. So 5 when you raise 4 times, 5 into 5, 25, 25 5 is 125, 125 5 is 625. So it's lying in between 256 and 625. So therefore result is going to be 4.9011. That way you are getting it. In that manner you are getting. So this is called as here quadratic root. We call this as here quadratic root. Okay, you have here, I mean, you can find here square root, you can find cubic root, quadratic root. Then similarly, you can go here with the fifth root, then you can go with the sixth root. Okay, so like this is working, and the method is what here, a method with the default parameter. So it's taking actually here default value. Okay, or you can call even this as a optional parameter. We can call this as here optional parameter. Okay, so like this can be an instance method, or this can be a static method. Method need not be always static. Sometimes it can be static method. Sometimes it can be instance depending on the requirement. When you have data, when you have state for the given object, in that case, you need to write the instance method to actually process the data. Okay, but the class is not having any data. Okay, there is no state for the given class. That means you cannot create, you need not create actually object for the given class. So in such case, you can write the static methods. They become actually ultimately their helper methods. Okay, so this is what exactly we are writing here, a root, and here we have one of the things as optional parameter. Now next come to, we define a function or method with variable number of arguments. You can go with actually n number of arguments here. Need not be always only one argument or two arguments or three or four. So how many you want to pass, that many you can pass. They are not going to be fixed here. Variable number of arguments we say. Sometimes you can pass only one argument, sometimes two you can pass, sometimes three you pass. And for the with the same method, you can pass n number of arguments. So for that purpose, we have to write like this. Public, then here write static, followed by, you go here with the double. Okay, then right here, this is what sum for arbitrary args. Okay, then here inside this, we declare here an integer array, we call it as param array. Param, then followed by here it is int, then write nums. This can be, need not be double value. You can go here with the integer for this. Then here we go with this, then try to pass here numbers. So basically you have here number of arguments there. Okay, number of arguments you are having here in this case. So let us go this way and try to do it. Basically, you have to use a loop in this. What is loop? Later on we discuss. Here go with this int, sum equal to here 0. Then what you do here, you go with the for loop. For here, int index equal to 0, then index less than nums dot length. Nums dot length, then this is here index plus plus. And here we need to go with, and we need to add here to the sum each and every index value. Sum equal to, we write this as sum equal to, so what do we write here? Sum plus nums of index. Okay, so here we are employing the array here inside this. There is an array, you are going to pass it as array. Okay, then here return num. We don't pass like an array, individual numbers only, you have in that case, return sum, here it is. We pass individual numbers separated by comma, then it's going to give you the sum. Okay, go here and try to now find the sum of the given numbers. Right here, int here sum equal to some 0 we take. Then right here sum equal to sum for arbitrary args. We take, and you can pass here numbers 2, then 4, then 5, then 6, like this we take. Okay, similarly, now you write console dot write line. Here write this one sum. Next time what we do, we go here with different numbers now. We just go only with the 3 numbers in this case. So it is here 20, then 40, then this is 50 we take. We take only 3 arguments now. So write again console.writeLine sum. In the first case, what value you expect? 2 plus 4, 6, 6 plus 6, 12 plus 5, 17 we get. But now how many you are going to be expecting? 20 plus 40, it is 60 plus 50, it is how much? 110. So try to run that here now. So how much we are getting now? First we are getting 17, next we are getting here 110. So 2 plus 4, 5, 5 plus 5, 10, 10 plus 6, 16 we have to get, but how much we are getting? 17 we are getting. 2 plus 4 is how much? 6. 6 plus 5 is 11, sorry. 11 plus here, 6 is 17, result is correct. And this is here, 110 we are getting. Once again, run and see here, you get the same result, 17 and 110. So here, first time we passed 4 arguments. Next time, how many we are passing here? Just 3 arguments. So this is called as here param array concept. Parameter arrays we passing. So this method can accept actually n number of arguments. If you pass 1 argument, it takes. If you pass 2 arguments, it takes. If you pass 3, it's going to be taking that. If you take, if you go with the 4 parameters, it can take 4 parameters. So how many you pass, they are going to be converted to an integer array. Then accordingly, it can be doing for you. So this is called as here a param array.